Hello and welcome back. In this particular video, we're going to be looking at sketching again more transformations of absolute value graphs. Okay, now this is relatively straightforward. We're going to use the same process as what we did in the last video. Okay, so what we need to understand is when we look at our function y equals absolute value of x plus 2, all right, because this 2 is on the inside of the bracket, it's moving horizontally. Okay, so we take our original absolute value graph and it will move it horizontally. Because it's a positive 2, it's going to move to the left a value of 2 units, okay? So without further ado, let's get stuck into graphing this and have a little bit of a play, okay? Just like last time, step 1, we're going to find our y-intercept, okay? So to find y-intercept, okay, we're going to let x equals 0. So therefore we have y equals the absolute value of 0 plus 2, which just gives us the absolute value of 2. And remember, the absolute value of 2 is just 2 itself. Okay, so our y-int is equal to positive 2. Step 2, we're going to find our x-intercept. So to find x-int, we're going to let y equals 0 in this particular case. Okay, so therefore we now have the absolute value of x plus 2 is equal to 0. Okay, now there are multiple different ways that we can decide to have a little bit of a play with this. Okay, again, I'm going to go down the path of just solving the absolute values and just do it by cases. Okay, so case 1, we have x plus 2 is equal to 0, so we end up with x equals minus 2. All right, and for case 2, okay, we have minus x plus 2 is equal to 0. Now that's just coming back from that formal definition of the absolute value. All right, I'm going to multiply both sides by -1, which will give me x plus 2 is equal to 0. And you'll notice that we end up with the same answer here. I really want to highlight this to you. We are expecting that because the vertex of our original graph hasn't actually been moved down. And if you think about our original graph, we only had one x-intercept. Okay, so all that's happened is that it's moved left 2 units. We're not expecting any more extra solution. So I'm just going to put in all of our values. I'm going to put in our y-intercept, which is equal to 2. All right, so I'll come up here to 2, and I'm going to do the same thing down here with our x-intercepts. We only have one x-intercept, which is -2, okay? So in that particular case, we have -2 occurring over here on our graph. Now, this is pretty much enough for us to graph straight away, but I always like to go ahead and just double check just before we move on, okay, what's going on and whether or not it's positive or negative. Now, if I look here, you'll notice that there's no negative out the front, okay? So it's going to be a positive graph and it's going to point upwards rather than pointing downwards. So now we know that we're going to be able to connect all of the dots, okay? So what I like to do, I like to draw and connect my y-intercept and x-intercept straight away. And remember, technically, normally if we were drawing the line y equals x plus 2, it would continue on downwards, but it won't in this particular case because it's now going to reflect upwards. Okay, so now, all right, I take my other branch of my absolute value and I draw it as it reflects off the x-axis, right? And so bouncing back off at that vertex. Okay, so now I've just drawn the graph of y equals x plus 2. And it's relatively straightforward to look at the domain and range of this, okay? So if you look here at this y value, thinking about the range, it's anything that is bigger than 0 and including 0, okay? So your range is going to be uh, from 0 all the way up to infinity, and your range is all of your x values because you can have all of them, okay? You might find it useful to use this little technique here when graphing them to sort of see how it behaves. I know I do, okay? And you just sort of create like a little bit of a dotted line just to get your general behavior. It is completely and totally up to you, okay? I'll rub that out just so you can see the official graph, okay? So I hope that helps, all right? In the next video, we're going to look at solving absolute value equations graphically. So rather than algebraically, which we've learned in our last lesson, we're going to do it graphically, okay? All right, thank you very much.